And we're live. Okay, the New Scientist posted this question on Facebook. It's a puzzle. So we're going to go through it and we're going to see if we can work it out. So yeah, what does it say? We've got this shape. It's made up of 4 squares, 2 small ones, medium one, and a large one at the bottom. We've got to work out the area of that red triangle. We know that the area of the small squares are 8 units. So, first of all, where I'm going to start is I know that triangles which have the same base and the same perpendicular height always have the same area. Okay, no matter how you draw them, the base of one is the same as the other, and of one is the same as the other, then the area will be the same no matter how skewed the triangle is. Okay, so let's see how we can apply that here. Straight away, I can see that this line here, I haven't put this on screen, have I? That's better. Okay, so let's make that a little bit bigger. That's more like it. Okay, so I can see that line there, I've drawn that black line in the middle. I can see that it's parallel to this line here. Okay, and that's just because we know that they're all squares, so they have to be parallel. Okay, so if I was to look at this red triangle, and I notice that this here is the base of it. Okay, so I'm going to just redraw that. So we've got the base over here. Okay, and the vertical height would then be between the distance between these 2 parallel lines. So the vertical height is then that there. Okay, but there's no real way of working that out from there. What we can do, though, is we can pick that up and move it. And if we notice, it should be approximately, if my drawing is correct, or my drawing isn't, so I'm going to redraw that. But my drawing is not actually accurate. So we should notice that it is actually the same as that line there. Okay, so we've got the vertical height, which is the distance between the parallel lines, and we've got the base. Okay, so now we know the parts that we're working at. Okay, because once we've got the vertical height and the base, we can work out the area. Okay, so the area of this blue triangle must be the same as the area of the red triangle, because the vertical height and the base are the same. So the blue triangle and the red triangle have the same area. Okay, awesome. All right, so now let's start working this out. So first of all, I'm going to work out the base. Okay, let's call it B, the base. So how do we work that out? Well, that base is actually the diagonal of the small square. So if we notice, it's just the small square diagonal. Okay, awesome. So how do we work out a diagonal of a triangle, which we know the 2 sides of? Well, it's Pythag. So we can use Pythagoras' theorem. So let's rub this out for a second. Pythagoras' theorem is a squared plus b squared equals c squared. Excellent. Okay, so a and b, because this is a square, they're exactly the same. Okay, and we know the area of this square is 8. So each side must be the square root of 8. Okay, so a and b are the square root of 8. So let's put those in. So the square root of 8 squared plus the square root of 8 squared equals c squared. Okay, and the square root of 8 squared, obviously these 2 cancel out and those 2 cancel out. So it's just 8 plus 8 equals c squared. So c squared equals 16, and the square root of the 16 is 4. Okay, so now we know that base of the triangle. So the base of the red and the blue triangle is 4. Okay, so I'm going to erase this. I'm going to write that in. So we know that's 4. Excellent so far. 4. Okay, we'll work that out using Pythag. Okay, let's keep going. Let's keep going. Okay, so now we have to work out the vertical height. I know it's not vertical in this, but it's perpendicular to the base. Okay. So, well, that's this length here. Okay, I'm going to erase that for a second. So that's that length there. And again, that is the diagonal of that middle square. Okay, so we have to work out the side length of each side of the middle square. So that side there and that side there. So we can use Pythag. Okay, so what is the side? Well, we know that the side of the small one is root 8. Okay, but it's 2 of those, so it's 2 root 8. So each side here is 2 root 8. And that one's also 2 root 8. Now we can use these in Pythag. Let's zoom out a little bit and let's do that again. So a squared plus b squared equals c squared. Okay, so a and b are the same because it's a square. The sides of the square are the same. So 2 root 8 squared plus 2 root 8 squared equals c squared. Okay, now we just work these out. So 2 root 8 squared. So root 8 squared is 8. 2 squared is 4. Times them together makes 16. 16, I lie, 32. What am I talking about? 32. And 2 root 8 squared is 8. 2 squared is 4. Times them together makes 32. And that's c squared. So now we know that c squared equals 64. Okay, so therefore c is root 64 and c is 8. Okay, so now we've got that perpendicular height. Rub these out. So now we know that's 8. Excellent so far. Okay, so now we've got the vertical height of the triangle, and that side is the same as the vertical height for the red triangle. Now if we work out the area of the blue triangle, that will give us the area of the red triangle because they're the same. And how do we work out the area of triangles? Very simple. It's half the height, the vertical height, multiplied by the base is the area. Okay, so the height is 8, so half of 8 multiplied by the 4 is the area. Half of 8 is 4. 4 times 4 is 16, so the area is 16 units squared, or square units. That was a fairly easy question. The math was quite simple. It's just knowing that you can move the triangle and keep the height and the base the same. Excellent.